Greetings, M squared here. Today we're going to review a little bit about our exponent rules, and then we're going to work on our new one where we're changing radical form to exponential form. Okay? So first we're just going to go through these. Now these are similar to the ones you have in your homework, so hopefully this helps. The first thing I want to notice is that I'm multiplying. That means I'm going to use my exponent rule that says when I multiply like bases, I add my exponents. But remember, coefficients get multiplied just like normal. 3 times 4 is 12, so I know my answer, my coefficient is going to be 12. And then I'm going to take b and I'm going to add up all of those. So that means -3 minus 4 plus 4. Remember, minus 4 is the same thing as adding a -4, so I just said minus 4. Well, what I notice here right away is that 4 and -4, those would cancel out. So I'd actually have -3 plus 0. So I only have b to the -3. But my directions say I can only use positive exponents. So 12b to the -3 becomes 12 over b cubed. And that's my answer. This is an appropriate answer, and if it hadn't said use only positive exponents, then I wouldn't have to change it. But since it does say that, I need to change it. So anytime there's a negative exponent, I need to make sure I get rid of that. There's different ways you can do this. You can do the fourth power first, or you could simplify first. It doesn't matter. I'm not going to simplify in here first because there's just one thing. If there were a bunch of things, I would. So what I'm going to remember is that anything without an exponent has an exponent of 1. So that's a 1. And why I did that was because this is the power rule. And that means I'm going to multiply my exponents. So I have to know what the exponent is before I can multiply it. Some people get confused and they multiply 4 times 4, but that's not what this is saying. It's saying 4n to the -3 times itself 4 times. So you got to be careful with that. So this changes to 4 to the 4th because 1 times 4 is 4. And it changes to n to the -12 because -3 times 4 is -12. And now I'm going to simplify it. So I don't think they make you actually do that. I think it's 256. So you can do that. It doesn't matter to me. But this is a negative exponent, and whenever I have a negative exponent, remember, if I move it to the bottom, it becomes positive. Because it's really asking, hey, that negative means what's the reciprocal of n to the 12th? And the reciprocal of n to the 12th is 1 over n to the 12th. So it goes down there. So you could write it like this. I believe that's 256, but you don't have to. This is an acceptable answer in my world. All right, let's try number 3. Now what I notice here is there's division going on. So remember, when division is going on, I subtract my exponents. I look at my coefficients and there's a 1 there. So I know it's going to be 1 over 4 because I can't reduce that. The reason I put the 1 there is because I notice there's more n's down here than there are up there. So there's a couple ways you can do this. You could say 3 minus 4, and then you could put n to the -1 up there. That's one way to do it. The way I tend to do it is I look and see on my n's, I see that the 4 is bigger. That means I have 3 n's up there, 4 n's down here. 3 are going to cancel. I'm going to be left with 1 down there. So that's kind of how I think of it. Another way to do that would be wherever the bigger exponent is, subtract that way. So 4 minus 3, and then they're going to be left down here. So my answer is 1 over 4n. All right, moving on to number 4. Again, it's a power rule, so I got to know my exponent's a 1. So I'm going to say 4 cubed, and n 2 times 3 is 6, because with my power rule, I multiply exponents. Again, that's an acceptable answer, but if they wanted you to simplify it, we would do 4 times 4, which is 16 times 4, which is 64. And that is fine as well. Okay, this one's not too bad. We're going to multiply our coefficients. I'm recognizing that it's multiplication going on, which means I'm going to add exponents, but don't forget, if there isn't an exponent, the exponent is 1. Now I'm going to add a to the 1 plus 3, but 1 plus 3 is 4, so I'm just going to put 6a to the 4th. All right, now I'm going to try this one's division. So I divide normal here. 4 divided by 2 is 2. And I notice that I have an exponent of 1 down here, but an exponent of -1 there. So the -1 comes down, and then I have an extra 1. You can think of it that way. do the reciprocal kind of thing, put the x down here, or you can just subtract. This one's biggest, so 1 minus a negative 1, and 1 minus a negative 1 is 2, so I've got x squared. So there's different ways to think about it. I've got x to the, in the bottom, x to the 1 minus negative 1, or you could have changed this x, you could have put it down there, and then you would have x times x, which is x squared in the denominator. And I put a 1 there, should have put a 2 there. All right. I got a 0. Zeros are nice. Anything to the 0 power is 1, so I know that's 1, and then there's nothing else to do, so it's just 1 over 4x. That was kind of easy. All right, so now, remember before I told you I wouldn't simplify the parentheses because there was not very much going on, but there's a bunch going on inside these parentheses, so I would definitely simplify them before I took care of that too. So the first thing I'm going to do is just look at my x's. I notice I have an x and an x to the 0, but an x to the 0 is 1. So I'm going to write down my parentheses with my squared, and I just finished simplifying my x's because that one canceled and I have only one other one, so I know that's an x. I'm going to put it right there. The next thing I'm going to do is simplify my y's. So I have a y to the 4th and a y cubed on top, but then I see a y cubed on the bottom. Well, remember, anything divided by itself is going to be a 1, so those actually cancel. I don't even have to add them. I just notice they're the same and I cancel them right away, which means I have a y to the 4th still up there. Okay, now I'm ready to take care of that. Remember, my x has an exponent of 1, and I'm going to multiply exponents. So 2 times 1 is 2, and 4 times 2 is 8. So my answer would be x squared, y to the 8th. All right, so now we're done with simplifying using our rules. This is our new rule where we learned how to rewrite it. We're not really doing any math, we're just rewriting it. So this says to change it to radical form. Remember, this is a radical sign. So all of these are going to have radicals, whereas in these next 4, they already have radicals, and I'm going to switch them to exponents that are fractions. So in case you forgot, this little number here is called the index. But if I just have the square root, I don't write a 2 there. You could, but it's not usually written. So if you ever have an index of 2, you don't need to write it. But any other time, if I had the cubed root of 5, then I would need to write it. So the index goes here, and then the power is that number that's the little exponent. So each thing is going to have an index and a power. If it's 2, we don't write it. If the index is 2, we don't write it, we just write a square root, and if the power is 1, we don't have to write that either. So the first thing I'm going to notice is that this is going to be my index because it's the denominator. This is going to be my power because it's the numerator. So you've got to get that in your head because you won't have those notes on your test. So first I'm going to write my 3x, and then I'm going to write my radical sign. And then I'm going to say, well, what's my index? It's 5, so I'm going to put a 5 right there, and my power is 6. And that's all I need to do. I just need to switch forms. So I'll do this one. So my index is the denominator, and my power is 1. But like I said, we don't have to write a 1, so it's okay to just write x because it's just a power of 1. Right over here. Remember, my index is 2. I don't have to write it because this without an index always means square root, so I'm not going to write it. That would be the proper way to do it. Then v, the power is a 5, so it's just the square root of v to the 5th. And then this one is x. My power is the top, the numerator. My index is the bottom, the denominator. Okay, that's how you change those to radical form. Now we're going to switch. We're going to go from radical form to rational exponents. So I write what's ever in the parentheses, and then I'm going to have a fraction. The bottom of my fraction is going to be the index. So that index says 3, and the power is going to be my numerator. So I would rewrite that 2n to the 2/3. This one is 4x, so I'm going to write that in parentheses. The power is 5, and the index is 3. So power goes to numerator, index goes to denominator. All right, so we have a 2x to the 4/5. Power is the numerator, index is the denominator. And finally, we have an n. Whoops, sorry. We have an n, And the power is a 2, and the index is a 5. And that's how you switch back and forth. So good luck with your exponent rules. Email me if you have any questions or need help. M Squared signing out.